So let's start. In the yesterday class, we have done the mesh analysis, right? Now, according to this, our next topic is nodal analysis. We have done yesterday mesh current analysis. Next one is node voltage analysis. Got it? So it's lecture 2, node voltage analysis. Basically, node voltage analysis totally depending on KCL, okay, or we can say nodal method, node voltage method, or nodal analysis, whatever we can say, or Kirchhoff current law, all the things are same, okay. So basically Kirchhoff is a scientist name, and on the basis of his name he gave two laws. One law is based on voltage, okay, one law is based on voltage and another law is based on current. Clear? So the law which is based on voltage, that is known as KVL, and the law which is based on current, that is known as KCL. Clear? What is the statement of KCL? He states that sum of incoming current would be equal to the sum of outgoing current, right? So now see, let's take a simple example to study that how we can do the questions based on the nodal analysis. Okay, like we have followed this number of steps in mesh analysis, similarly we'll follow number of steps in nodal analysis. Clear? Now step number 1, we have in the mesh, what was the step number 1? We have to determine number of meshes, right? But here we have to determine number of nodes. What is node? Basically, node is a point where more than two branches or wires must be connected. Clear? So this is one of the node A and this is another node B. Can we consider it? Is this a node? This one? Because it consists of two wires only. And this one is also the node. This one is also the node, right? But the lower node or the voltage across VC and VD would be same because it's a plain wire, right? So in that case it would be grounded. Clear? So ground means the potential would across that would be 0. Correct? Understood? Now step number 1 done. Two nodes means two variable and two equations. Okay, like one of the variable is VA and another of the variable is VB. Now move towards step number 2. We have to mark current direction. What we need to do? We need to mark current direction. So in this case we'll mark the current direction in the branches only. I1, I2, I3, I4 and I5. Clear? Now in the step number 3 we have to apply KCL at node A. Okay, like just imagine this is your college, VA is your college. Okay, so tell me which current is entering into your college and which current is leaving your college. I1 is entering or leaving? See the direction of current. I1 is entering into the college or leaving the college? I1 is entering. So the current which is entering would be on one side and the current which is on leaving side would be on another side. I2 and I3 are leaving, so make I2 and I3 on the another side. Clear? Now just imagine I1 is you. I1 is you. You are moving from here, the potential is 0. 0 to VA or VA to 0? Like just imagine this is your home. Now tell me, I1 is moving from 0 to VA or VA to 0? Okay, just this is your home and this is your college. You are I1. You are moving from home to college or college to home? Home to college, right? Means you are moving from 0 to VA or VA to 0. Now tell me. 0 to VA. No, we don't see the potential. We'll see the current which we have marked the direction. Okay. So randomly, it's not necessary that we need to mark it according to the battery direction. You can mark it according to your own convenience. So now again I'm asking the same question. I1 is you. You are moving from home 0 to VA or VA to 0? 0 to VA. So it would be 0 minus VA. Okay. And in between, if you'll have battery, do you have battery in between? And we have to take the second sign of the battery. Can you tell me what is the second sign of the battery? Plus, because you are moving from 0 to VA. So what is the second sign that comes in your path? Plus. Plus 11 divided by the resistance 4. I3 is moving from VA to VB. So it would be VA minus VB minus 8 because second sign divided by 7. Right? Now similarly apply KCL at node B and tell me all the equations. Okay. I3 is entering. So I3 would be equal to I4 plus I5. Now I3 is how much? Now for node B, we got these equation, right? If you have any doubt, then you can ask from me that how this equation will come. Okay. Now we need to solve this equation, right? These are the two equations. See how we need to get the value for VA and we need to get the value for VB, correct? So see how can we solve it. I'll tell you the easy method. Make it separate, like VA by 7 minus VB by 7 minus 8 by 7. Okay. Similarly, VB by 9 plus VB by 9 minus 12 by 9. VA VB on the left hand side, constant term on the right hand side. Okay. Like VA by 7 minus VB by 7 minus VB by 9 minus VB by 9 equal to minus 12 by 9 plus 8 by 7, right? We can take VA common, it would be 1 by 7. We can take minus VB common, it would be 1 by 7 plus 1 by 9 plus 1 by 9, right? And convert it into point value. Then you will get some constant value, correct? Only through calculator do this one, this one, this one and this one and the combination of this one. Then you will get one particular equation of VA and VB. Now similarly you can do it for this one equation, right? So now you will have two variable and two equations, right? We can solve it in calculator easily, correct? You know now how to solve two variable equation in the calculator. Yesterday I told you, right? Now this is one of the variable is VA and another of the variable is VB. Got it? Okay. Now see, if suppose they ask you to calculate the current of I4. I4 is how much? VB by 9. After solving, you will get the value for VB, then you can substitute in I4. Practice of VIT, right? Practice sheet that is given by your VIT teacher. Let's do practice. First question, using mesh analysis, determine the current through 5 ohm. So one of the question will definitely come from these kind. Okay. Now you already know the mesh analysis which we have discussed in the yesterday's class. So in this, how many meshes are there? 3 meshes, I1, I2 and I3. So first step, mark current direction. Second step, mark sign convention, right? So we'll mark the sign according to the direction of current, right? Now we have to take the second sign. Like properly you have to write on that, apply KVL in mesh 1. Okay. So what would be the equation? Tell me for the mesh 1. Hmm. 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 Minus 2. Yeah, sorry, it's 2, not 12. I1 minus I3. Now similarly the second equation is plus 10 minus 4I2 is equal to 0. This is your second mesh equation. Now similarly tell me the third mesh equation. Hmm. 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 Yes. So this is your first mesh equation, second mesh equation and third mesh equation. After solving first mesh equation, we'll get this one. For second mesh, this one, and for the third mesh, this one, right? Now directly put it into the calculator, and after solving, what they have asked, they asked to calculate the current in 5 ohm. And how much is the current flowing in 5 ohm? That is I3. But you should get the answer, that is 3.38 ampere. Okay. If still you will not be able to get the answer, then you can tell me. Next question is nodal analysis, that is given by your teacher only, VIT. That use nodal analysis to determine the current in 10 ohm, right? So first step is we have to determine number of nodes. This is the node V1 and this is the node V2, right? Next step is to mark current direction I1, I2, I3, I4 and I5, right? Next step is to apply KCL at node A, right? So tell me what is KCL? I1 is equal to I2 plus I3. I1 is how much? As you can see that there is no resistor. No. There is no resistor. Okay, whenever there is no resistor, that means it's a super node. Or you can say directly also that as you can see that there is no resistor, so we can simply consider V1 as 50 volt. Okay, so now we got the value for V1, that is 50 volt. Now we need to apply KCL at node B, V2 sorry. So it would be I3 is equal to I4 plus, now tell me the value for I3. V1 minus V2 by 50. Correct. I4 is how much? By 20. Correct. V2 minus 10 by minus 0 by 20. And I5 is how much? V2 minus 0, 10. So in this equation, we already know the value for V1 is how much? 50 volt, right? 50 minus V2 is there now, right? Now only one variable is left, correct? So we can substitute 50 minus V2. Now we'll have a single equation, only V2 is the variable. Can we solve it for V2? After solving V2, let's see what they have asked. They ask you to calculate the current in 10 ohm resistor, right? I5, yeah. We have to find V2 and I5. I5 is how much? V2 by 10. So whatever we got the value for V2, we can substitute it here. Then we'll get I5. So like this, you can check the sign for V1, right? If suppose the battery is opposite, suppose like negative and positive, then the second sign would be negative. Current is moving from 0 to V1, so 0 minus V1, and the second sign of the battery minus 50 is equal to 0, so V1 would be equal to minus 50. Okay, this is just I'm telling you for your understanding, because student won't be able to recognize the sign. So don't do this mistake, do it like this method. I1 is moving from 0 to V1, so 0 minus V1, and we have to take the second sign of the battery. So from here you can judge whether the sign is positive or negative. Clear? Now the next question, question number 3rd. Okay. They said find the current through 10 ohm resistor connected between points A and B. Now see, if you'll solve it by mesh analysis, 1, 2, 3, 4, there will be 4 meshes, right? So it's better to convert current source into a voltage source. Okay, so that is known as source transformation. That is known as source transformation. So this is also in your syllabus. What we can do in source transformation, here current source must be converted into the voltage source. But there is one condition, that current source must be connected in parallel with the resistance. If current source is connected in series with the resistance, then in that case it won't be able to convert it. Okay. So the same resistor which is connected in parallel, that same resistor must be connected in series with the voltage source. Got it? Now suppose there it is 10 amperes. So according to Ohm's law, V is equal to I into R. I is how much? 10 ampere. R is how much? 5. So it would be 50 volt. So here there are two meshes. Here it would be converted into single mesh. Correct? So now see, this is also current source is connected in parallel with the resistance, right? So we can convert it into the voltage source. Now you convert and redraw the diagram. See, in this case current is moving downward, so our battery sign is also like that, it should move downward, current should move downward. Okay, first thing, 20 ohm resistor you can place it upward, or 20 ohm resistor you can place it downward. That is totally depending on you, whatever you want. Okay, so now you can see our 4 mesh question will be converted into the 3 mesh question. Correct? Now it will be easy to solve. Correct. So now first I am telling you the 3 equations. They ask you to calculate current in 10 ohm. That means they are asking I1. So that would be 10 minus 10 I1 minus 20 I1 minus I2, and that would be value is 20 into 2 40, right? Plus 40 is equal to 0. Second mesh equation is minus 20 I2 minus 20 I2 minus I3 minus 40 minus 20 into I2 minus I1. Now third mesh equation is minus 40 I3 minus 100 minus 20 I3 minus I2 is equal to 0. Correct? Now you can solve all these three questions, then you will get the final answer. Now see, I tell you first before moving towards the next question, super mesh. Okay, whenever there is a current source, there will be a super mesh. Okay, now this is, suppose this is the current source, arrow is there, that means it's a current source, right? So just imagine, like, current source is your enemy, right? So now tell me what you will do with your enemy. Just imagine the face of your enemy, and suppose he or she is in front of you. Then tell me what you will do in that case. Kill him, or if you can't kill him, you will avoid the path where your enemy is present, right? In this case, current source is your enemy, you killed him and replace the voltage source. Here you are standing at A, you need to move towards A only, right? Like suppose you are moving from A to B, you saw your enemy, then you decided you may choose the longer path, but you will not go through the path where your enemy is present. Correct or not? Hmm? So this is technically known as super mesh. Clear? If we avoid the path of our enemy, we will go through the longer path, that is our super mesh. So now apply KVL in super mesh. That would be same thing, whatever we'll do. Minus 4I1, right? Minus 6I2 minus 20 plus 10 is equal to 0. Now we need one more equation. Another equation will make it from the current source. Okay. Now tell me, I1 and 8 ampere, they are moving in the same direction or in the opposite direction? Opposite direction. I1 is moving from up to down, and 8 ampere is moving from up down to up, right? See this. So if they are in the opposite direction, then minus I1. Now if they are at the same direction, 8 ampere is also moving up, I2 is also moving up, so it would be same direction, that would be plus. So now we'll have two mesh, two variable and two equation. Note it down. Now in this, if current source is in the middle branch, then there will be flow of double current, but if current source is in the corner branch, then there will be flow of single current. Okay, as you can see that current source here is in the corner branch, right? So I1, I2 and I3 and 2, yeah, I3 direction and 2 ampere direction, they both are same or opposite? Same. So we can say I3 would be equal to 2 ampere direct. Okay. Now we'll need to make two mesh equation only, like three variable, three equations. So this is the third equation. Okay. From the first mesh, again the same, minus 10 I1 minus 4 I1 minus I2. I think now you are perfect in making equation, right or not? If still there is any doubt, then you can ask from me, okay, or you can drop me a message on this number. Now you can solve this equation, then you will get the answer. Now see what they have asked. They asked you to calculate current in 20 ohm. 20 ohm means I2. So your I2 should get 0.61 ampere. This is your next question. It is based on Kirchhoff current law. Okay. So now see, as you can see that this is the node, right? This is current moving outside, outside, inside, outside, right? So the incoming current would be on one side and outgoing current would be on another side, right? So incoming is I2, outgoing is 9 plus 4 plus I3, correct? So from here we can get the equation, that is I2 minus I3 equal to 13. Yes or no? Let us consider the current flowing here would be I4. Okay. So if we'll apply nodal analysis at this one, then can we say that I1 would be equal to I2 plus I4, right? Let us consider mesh analysis. So I4. So for I1, equation is minus 12. Yeah, minus 12 I1 minus 8 I1 minus I2 is equal to 0. Second mesh equation is I2 is equal to 9 ampere. Third is I3 equal to minus 4 ampere, right? I2 is 9, I3 minus 4, and then you substitute here, then you will get the value for 1. Got it? Now next question is also related to mesh analysis. I1, I2, and but they have minus I1. Generally we take, I don't know, let's take it according to, so for the mesh 1, minus 10 I1 minus 10 minus I3 minus 10 I1 minus I2 plus 100 would equal to, right? For the second mesh, minus I2 I3 minus I2 equal to 0. For the third mesh, I3 I3 1 would be equal to 0. Looks like confusing. So now last and important question. In this, have to find voltage, right? So as you can, point A point is here. As you can see that we have don't direct connect A and B, right? Can we move path A, B, right? Much V plus V plus V, how much? Can we say that according to Ohm's law, IAC to RAC? RAC is how much? 3 ohm. How much? They already the voltage 8 volt. Now VDB is how much? IDB, RDB. RDB is how much? 3 ohm. Now we have to consider the sign also, as I told you, always have to take are moving from A to C. What is the put minus? C to D. What is the second sign? Negative. Negative. D to B. What is the second sign? Plus. Plus. Okay. Now IDB we can get it directly, right? You are moving from E to B, but your current is moving from to. They are moving in same direction or in the opposite direction. Can we say that IDB equal to minus I2? And I2 value is how much? 5 ampere. Can we say that IDB equal to minus 5? Now IAC. Now get IAC. We can apply. You are moving from A to C. Current is also moving from A to C. Positive. Minus 5 I1 minus 8 I1 is equal to I1 would 10 by, correct? Then solve it. Then you will get the final answer as 0.25. Important question also mesh analysis, correct? Now tell me out of two. So now I have any of the questions rest of the from the Thevenin theorem in the part 2. If you have any doubt related to the subject or any doubt related to queries, if you can contact me on Twitter. My name is Charu, and if you need any doubt classes, doubts, or if you want to study particular CAT exam, as you know, it's very near, you can also contact me, and please forward this video to friends as well.